They're not a pair. They don't depend on each other. Okay, I agree with that. And they don't give you standard. Ugh, I'm freezing right now. Blanket. Oh, okay. Interesting space. It would be 99%, right?
No.
It says which of the following would produce a confidence interval with a smaller margin of error when you increase the.
Okay. As your sample sizes go up, your margin of error goes
smaller.
Oh.
So I did the last one.
So increasing the the sample. Let's see.
Change the balance of 90.
30.
Yeah.
Okay.
She talked about that in her video in like the beginning of it.
She did. I remember.
Yeah, I had to go back and remember that.
A factory mix.
Oh, this is the one where I was not sure I did correctly. So I don't know.
Did you get 1.96?
Okay, then I totally did this wrong.
I did it right though.
I don't know if I did this.
Okay.
So
you need to find margin.
Because on the sample one, it gave it, or the whatever it's called, like the the preparation one, it gave us like the numbers already, and so I said it was B.
Wait, what number?
But
wait, we're on 6.
Yeah, but this one is on the preparation one.
Okay, yeah.
And it gave us like the numbers already. And I said it was B, which is 996 point whatever, and then 1003. So that's why I don't know if I did this right.
I think, okay, so the margin of error formula is
X bar over Z sigma. That one?
Oh, see, I did a different formula.
What formula did you use?
I used
Z times sigma over.
Okay.
Where is it?
So this one we don't use the X bar.
No. Well, when we need to find the confidence
margin of error. Okay.
Yeah, I did. So I did the 1 millimeter minus 2 times 2, and then I did 1 millimeter plus 2 times 2. That whatever that formula is called.
Confidence interval.
Is that a different one? Okay.
The margin of error is only a portion of the confidence interval. So margin of error is Z, so it's 1.96 because that's the 95%. 96 times sigma divided by square root of 4 because that's n. Stop it, babe. And that's 1 point. I got 1.96.
96.
Wait, what was the formula? I couldn't hear you. It was Z what?
Z times sigma over square root of n. I'm sorry, my baby's sick. She's being a.
Oh, that's the margin error? Okay.
Wait, I got 1.96. That doesn't make sense. Hold on. Wait, so we did the margin of error, which is 1.96 times 2 divided by the square root of 4, correct?
Yeah. 1.96.
Oh, okay. So I got that too. I was thinking I did something wrong. Okay. So then determine them. So the answer is 1.96.
Yeah.
Yep.
Okay. The lower bound.
So we do 1,000 minus 1.96 now.
Oh, I got the upper and lower bound for that one. That's what I did wrong.
Yeah.
So then you just do what for the upper and lower?
So is that
You
the
do the
formula
mean.
that I did? It's the mean minus 2, because that's the 95%, and then times the standard deviation, which is 2.
I don't know
Right.
what you're getting with 2. No, it's 1 mean minus the margin of error.
So minus 1.96 and
Yeah.
plus 1.96. So the lower bound would be okay.
Oh my gosh, I don't understand any of this stuff.
Oh, whoops, did it the wrong way. So it'd be
Here, I'll type it.
980.
So ME equals, what is it? Z times sigma over N. Okay, so that's the margin of error. Do you see that? The
Yeah.
confidence intervals X plus and minus. So there's two of them. Remember, it's like blah and blah inside the parentheses interval. So CI equals X plus and minus ME.
It looks more complicated than it is.
Okay, so what did you get for 7?
So then it's 99.8.04, right?
Yeah.
And then for the upper bound, we'll do 1001.96.
Yeah.
Wait, what are you guys doing?
Margin of error, all you do is subtract it for lower bound and add it for upper bound.
So it's 99.
Did you get that?
Yes, I did.
I got the answers, but I don't know how you guys got it, but it's fine.
Are you sure? It's right. So our mean was 1,000, right? Or sample mean?
Yeah.
Okay. And our margin of error is 1.96, right? So all you do is 1,000 minus 1.96, and you get lower bound.
Oh.
Does that make sense?
And then you just
And then you add it to 1,000 plus the margin of error, which is 1.96, and it equals
That's the upper bound.
the upper bound. Yeah. Does
oh, okay.
that make sense?
Yeah.
Okay. To assess the accuracy.
So this is the formula to get this one equals. Do you have that in your notes somewhere? N equals Z times sigma over M.
Which one is this one? And so this is when it's known, right? Sigma known, because they have it. N equals Z times, is that the one you're talking about? With the parentheses and it's squared?
Yeah.
Okay, yes, I have that one. Wait, how did you know it was this one?
What is the sample size you need? And that's N.
Okay. Got it. So then we just plug it in. So the known is 1 gram is repeatedly repeated total times n times, and the mean of the weightings is computed. Suppose that the known mean rule. Okay. Is 0.01. Wait, so are we solving for n or n equals 1? Okay.
So n equals, and then
And then, so the margin of error would be, what is this? 0.0001.
yeah,
And then the 95 is, let me see, 1.96. Okay. Then we square root it.
divide by m,
Yeah, divide by m and then square root the whole thing, right?
square it.
Squared. Yes. I meant that, but anyways.
Okay, good. I don't know. I was like, well, I hope she's pressing the right thing.
No, I can't show you the picture right now. I don't want to mess up my computer. What times 0.01.
Alexis, do you know what formula we're doing?
No, I can't hear anything because it's like all scratchy. So
It's in lesson 10. If you're not sure which formulas we're doing, it's in lesson 10. Alexis, can you hear me?
yeah, I can't find my lesson 10. Not like 9. Wait, why does it skip lesson 10?
I got 38416.
Me too.
Did you do x bar minus z times standard deviation divided by the n squared?
No.
That is for confidence interval.
What formula did you use in lesson 10 then?
For n?
So this one, it's n equals z times sigma over m, and then that's squared.
Okay. I don't have that written down. Why do I not have that written down? Oh, right there. Oh. Okay. And you got 38416. There's no decimal.
That's right.
Okay. Is this one the last one? Less than 1,250?
Yes. Okay, 11.
Oh, wait. Are you guys on? Did you do 10?
Yeah,
Yeah,
10 was
it's-
the last.
Sorry. All right, so number 4 is 10, right?
Yeah.
Okay. We'll test how high the wheat. Say we check the null. If
This one I didn't understand what they were really asking.
They're asking when do you reject the null, and it's if p is low. So if p is lower than alpha,
Less than A?
so, then it's the second one.
Okay,
Yeah.
that's what I thought. Okay.
I know it's all these. It's so much word problem. It's not really math. It's like word problems.
I know. I hate word problems.
I'd rather do word problems.
Oh, you do?
Yeah, well, because I get all the formulas mixed up. I'm like, okay, we're going from the first section all the way to like lesson 15. I'm like, hey, which one do we freaking use? I'm just so confused.
No.
Oh, this one I did not know either.
I think they use ANOVA because ANOVA is when you have multiple data.
Yes, and they're using 4 different apartments.
So it's yes.
Okay, can they use
Yes.
ANOVA? Is there enough data?
And it's normal data, and the variances are almost are equal. So that's
So it's the
Yeah.
third one. Okay, that's what I thought too. I didn't know if I was correct or not.
I know it's hard. Really tripping me up this review.
Yeah.
I know, I thought we'd be using more of the SPSS.
We do later.
Oh, okay. The medical researchers working on a new treatment for a second. So she has 3 subjects. Let me see.
Don't worry about it. Just go to the next paragraph.
In the future study is to Oh, I don't remember what the type 1 and 2 errors had to do with.
Okay, I'll read you what I have. So it's a
What?
type 2,
What lesson is that in?
9, I think.
I couldn't find what lesson it was either, and I was trying to find it.
Lesson 9.
I think it's in lesson 9.
Oh,
Yeah, it's
that's right. Type 1 and 2 errors. Okay, I remember now. The truth table. Okay, even though the sample is small, results are significant. Consequently, she rejects the null. So if you're saying it's a type 2, then they failed to reject and it's false.
Wait, let me see. Oh, type.
But
Is
she
it type?
rejects it. So
Reject HO.
yeah, so she rejects it. It would be
Type 1 error.
correct.
No,
It would be.
she rejected it, but it should have been true.
Okay, hold on. In early trial, she tries the new treatment through.
Oh, so yeah, type 1.
So she did a type 1. So it was true, but she rejected it.
Yeah.
Okay. Oops. Okay. If the level size of A is made very small, then oh, well, it would be reduced. By reducing probability of committing a type 1 error. Oh, I have this written down too.
Remember how I got this one wrong last time? I kind of can't remember.
Okay.
But I think if probability of type 1 is small, then type 2 goes up.
Yeah,
Right here it says when one probability goes up, the other goes down. In my notes.
a sample size increases the width of
So I
confidence. No, that's different.
I think it's A.
Okay.
You have it written down, Alexis?
Let's see. By reducing the probability of committing a type 1 error, we increase probability of committing type 2. Yes, because they're opposites of one another.
Yeah. It says in my notes, when one probability goes up, the other goes down. That's all it was saying.
Yes, because these are opposites. So
yeah.
I hope that's right. Okay, so for whatever number that is, the next one. HO. So you do it and see what you do. Here's what you have to do. You have to find And then use the applet.
Okay. Got it. Go change the diaper. No, it's not going to increase this.
What formula is this one?
So this is for one known. So z, so it'd be z equals x bar minus mu over, divided by
The n.
standard deviation divided by n. So, wait, for z.
You mean n squared divided by n squared?
No, yes, sorry.
Okay. No, it's okay.
I always do that when I'm reading it. Okay.
So, x plus 1.53. What is the mu? Oh, 1.5. Divided by standard. 7. Where's n?
Wait, there's no n.
Oh, sample is 100 n.
What, there are 100 cigarettes? But
Yeah.
then what is mu?
Mu is 1.5.
Is that it?
Yeah.
Okay.
Okay, this is where I always trip up. So 1.53 minus 1.5 equals 0. So I got 0 or 0.016 or 8 if you're gonna round it.
I got 1.765.
Yeah, that's what I got. I just rounded it earlier.
Okay. And so this is actually greater than our level of significance. So if it's high, we keep the guy, so we fail to reject. So it should be the third one. Which one did she say she did?
I think she said reject.
I'm gonna do it again. Sigma.
What?
I think she said reject HO. Is that what you said, Victoria?
Give me a sec. What's n again? 100?
N is 100, yeah.
Okay, no, that's just z. Now you need to plug it into the applet.
Oh, the applet.
Oh.
You're absolutely right. Man, I'm so glad you're here.
It took me like 100 years to figure out. I was like posting on the discussion board, all stressed. Like
I completely forgot all of the stuff we learned.
So what are you typing in for the z? It's the 0.01.
No, 1.765.
So it's 0.0776, but it's still greater than.
Listen, you only highlight above that.
Oh, that's. Oh no, I'm doing really bad. Okay. We're only highlighting here.
Just to the right.
Oh man. Now you got me worried about this test. All right, so then it's less. You're right.
So it's reject HO.
Mm-hmm. I very much so needed this review.
Me too.
So we reject HO, the last one. Okay. You would like to look at the mean number of hours worked for wages per week by male students and female students. You would like So it would be independent sample t-test, right?
Yeah.
Second one.
Yeah.
Educator is interested in achievement. So this is going to be dependent. Okay. So dependent selling the sister's achievement depends to some degree on the brother's achievement. Collective brother, so as to wait,
I think it's the last one.
because it's just,
Select the brother, you have to select his sister.
oh, from what it said in there, she says use brothers. Wait,
Brothers.
sister pairs. Got it.
Is that just because she says brothers first?
No.
Is that
No, but the sister's achievement doesn't depend on her brother's achievement, but you select the sister because you selected the brother.
Oh, it says okay. You're right.
Select. I think it's depending on how you select.
I agree. Is the point
Aren't dependent on each other, but how you select them are dependent. We're gonna start opening.
Okay. I would like to constitute 95 constant interval.
But it's only one data set, so it's confidence interval for mu when sigma's unknown.
the first one?
Yeah.
Okay, I agree with that. If this lets me do it. Come on.
Hold on, I'll be right back. I'm gonna go check on.
My thing is taking forever once again. Does yours take this long to open up?
Sometimes, but it's because you have your camera on. You're screen sharing, and that's why it takes forever.
Okay. Which of the following is 95% interval for this analysis and put your answer to the margin of error? Okay. So now I got to remember how to do this. This is for unknown. Let me pull up my.
So you just explore. You just go to analyze explore.
Oh, I thought I had it written down for how to do SPS for this one.
But it's the first one we did, so it's just analyze explore.
That's it? I mean,
Uh-huh.
descriptive. Okay.
But here's what would change. If it wasn't 95 percentile, you just change the statistic.
Okay. So then we just move this over.
Yeah, check the statistic.
It's always set usually at 95. Yeah. And then we don't need to do options, just okay?
Yeah.
That's so easy compared to all the other stuff you have to do. Okay. I don't remember though for the margin of error.
Okay, margin of error
Is it?
Oh, babe. Is upper bound minus lower and then divide by 2.
Oh, that's right.
Charlotte.
Where does it say this in my notes so I don't forget it? Okay. So it is. Where's upper and lower? Upper and lower. Wait. So did you get 2.02452? 2, 0,
Yeah.
2, 5. Whoops.
2.0223. Okay.
What did you do? 3?
I did that. So just 3 decimal points, I mean.
Input the lower. Oh. Okay. Alexis, are you there?
Yeah.
15.217 for upper bound, right?
Yeah. 2, 1, 7.
Okay, this next one confused me a little bit. Oh, wait. Is that what you got? No.
Which one? No, question 22? You said you didn't understand?
I just am unsure.
Wait, this is a different problem, right?
Yeah, so you have to open up used Hummers, NY, and LA. Hi. Hi.
Oh, come on. Come on. Let me click you. It's not letting me click it. What is going on? Go.
I'm just not dependent or dependent, but I think it's independent. Well, let's try. Oops.
The 4 types of comment intervals listed below. Which one is appropriate for this situation? Hold on, I can't even see the problem anymore. Okay, so we want to know if there is a difference in mean listed price between Hummers for sale in Los Angeles, Group 1, Hummers for sale in Group 2. And listed below, confidence interval for the mean difference using dependent. Yes, number 3, because they're not dependent on one another. And
Okay, I don't.
wait, but we don't know. But we don't know the standard deviation.
Or, yeah.
Unknown. So that it's assuming that it's unknown. Don't worry.
Okay, so then it would be 3.
Yeah, okay.
Calculate 95% interval differences in means. All right, so this is where we have to do the whole independent one, right?
Yeah.
Let me find my paper of instructions. Testing. Right. So for this one, we do the recode first, right?
Yeah. Hi, baby.
Oh man, this is a lot of information to recode. So what we're trying to recode is the year.
Sorry, for the automatic
No.
code, how do you know which one to recode? That's what I get
Hold
confused.
on.
We're in the city. Go to the city.
The city? Oh, that's right, Los Angeles. Okay. So city, then city code. Okay. And after we do that, we do this is where we go to analyze next.
Yeah.
And then
Compare mean.
compare means independent sample t-test.
Yeah.
And then so the test variable, then
Price.
price. And then this would be the one that we made, right? City code group.
And then you have to define groups.
And then just 1 and 2. Continue. You do, no. Okay, and then this will give us our lower bound.
And we just do the top one, right? We do of the 2 lines, we do the top one.
Yes, that's what I remember. Wait,
No, you do the bottom.
was it the bottom or the top?
The bottom.
I don't remember.
It's the bottom.
But then I remembered you did, it was the same line as the F and SIG.
No, I remember when she said that when there's 2, you always look at the bottom. You never look at the top.
I don't even know. I don't remember. Are you checking the lesson? Oh, did they have the same question on the prep and did you get it right or wrong?
The answer key.
Oh, well that doesn't help.
Okay. Go.
Are you checking the lesson?
Okay, the results of 2 tests will be given. In this course, we will always conduct the analysis using the equal variances not assumed. So bottom. Alexis is right.
Well, I'm glad we got that cleared because I probably would have messed up. Okay, lower. So then it's negative 423.158. And then upper would be 54.7.256. Whoop, yep, that's right. Alexis, are you able to see this too?
Oh yeah, I already typed them in.
Okay, sweet. All right, so we're already doing another one. Wow, this moves so fast. What is the current test for this situation? So it's just shown that there's only so 3 groups. So this is ANOVA, right?
Yeah.
Is this 30 questions?
It's 32.
32.
We're almost there. Come on, open up, please.
Okay, test statistic. I got 7.978.
Calculate the test statistic. Okay. And we just get this from doing the regular, the Q plot, right? Or do I have to,
I always just do them both, so I can't remember.
okay.
So analyze, compare means, remember which one.
Think, okay. Now the dependent is the treatment, right? Whoops. Wait, string variables are not allowed.
Bone density.
Okay, see, this is where I'm going to completely mess everything up.
And then go to plots, yeah.
Okay.
So no, now you have to do the, whatever the other one is that you didn't do to get the test statistic.
Oh, then I have to do step 2, automatic. Man, you go through yours so quick. I think that's great. Okay, variable. This
It is treatment.
is treatment. Because I haven't done the test still yet. Right? So I have to go back and do analyze.
Yeah.
And then compare means. This is where I do. And then the dependent list was. See, I still don't know. Is it this one? Yeah, okay. I can't remember. Do I do options? Yes, I do. Scripted. Okay, then for the.
It's right there. It's right there.
F?
Yeah, that's the
Oh,
test.
that's right. Because it's different. 7. Okay. Okay. Give the p value, which is sig 0.022. Which of the following best expresses the calculation of this test? So then it's less, so we reject.
That's not an option. It's
So we have
the fourth
sufficient.
one. Sufficient evidence to conclude that the mean bone density of at least one of the groups is different. So that's what the conclusion is. At least one of them is different.
Yes. 3 is different. Okay. I agree.
What?
What? Oh, is there, you think there's more than one?
Oh, okay, no, here's what she said in her video. You reject the null, but the conclusion you talk about alternative. So you don't talk about the null in your conclusion, besides saying that you reject it. Right above it. And that is true, but in your conclusion, you talk about the alternative hypothesis.
Mm.
So it's the fourth one.
Mm-hmm.
Do you remember that, any of you?
No,
From the video?
I didn't finish it.
I can't remember when she said that. Stop it.
No, I do remember her talking about something like that, but I don't I remember exactly. Okay, so save that. Now we gotta do another one. Oh my goodness.
So transform automatic recode. Actually, I don't think you automatically recode. Transform compute variable.
See, they're available. Oh, this is like the other one we did, the flight one. So this was, is this dependent then?
No.
Wait,
Maybe it is. Yeah. I don't remember. God.
hold on. Oh, we solved this one, but I don't remember it. Okay. How do we determine if there's a difference in the mean cost of an airline ticket purchased 90 days in advance of a scheduled flight compared with the ticket purchase?
Yes, it's dependent.
Because it's from the same flight
Yes.
service with the European flight. So dependent, and it's point.
And then there's the difference, and you make sure you do 14 minus 19. Or no. Calculate the test. So analyze, compare these.
Okay. Calculate the test statistic. Okay, so for paired.
Here, I'll watch your screen if you want.
Okay, so I'm supposed to transform and compute variable.
Yeah.
Oh man, how am I going to put all of this on my notes for this exam?
You know what you could do is you could make a little box and title it SPSS instructions, and for each type, just do arrows. So like the button you click, and then an arrow, and then the next button you click. I think that's what I'm gonna do.
Yeah, well I think I have like a page for each one. I'm sure I could condense it. It just seems like it's so much. Okay, so that's right. We do the target variable, which we can make up to be, wait, what are we doing?
She went 14 minus 90.
So, but don't we write, oh, difference right here. That's what we write. So 14, yes, because I was taking last week's quiz. I got it right, but I sat here for a long time just trying to remember what I was supposed to do. And then, okay. And then we're supposed to we don't have it yet. We're supposed to go to analyze, right?
Yeah.
Analyze, descriptive, explore. And then for the dependent was the new variable. See, this is where it always messes me up because I still don't know which one goes where. 14 days, 90 days.
Wait, let me watch. I'll look at your screen.
Okay, dependent.
She said 14 minus. Oh, what is this? What is this that you're doing?
I'm analyzing it.
Difference. You're doing the difference because that's what you made difference for.
Yeah. So then I just do 14.
No. Go down and click difference. That's the one you just made.
Oh, okay. So that's what I put in the dependent list.
Yeah.
And then for my factor.
No factor.
Nothing?
No, you're doing too many steps.
Histogram?
Sure.
Oh, wait, it doesn't matter. Okay. What am I supposed to do? Options?
No, that's only when you're doing ANOVA. Do you need to do all of that stuff here?
Okay.
Go to bed.
Oh, I'm so worried. Okay, I still haven't done compute test certificate.
Yeah.
So
Yeah, so now you analyze what? This should have been here. It should have been yeah, one sample T. And then difference. I don't know what you just did before. I don't know what the other stuff was.
Oh, that was if you're supposed to change the confidence. I have notes for changing the confidence level if you need to.
Oh.
Oh wait, and if we don't have a mu, do we?
It's
The 0? It's 0.
oh yeah, I forgot about that. When do we put that in?
We only do, hold on, let me see the, not for this one. I believe it's 0 because remember when we write it out for,
It's for when they're dependent, but there is no
yes. So it's 0 right now. So we're okay. Okay.
Ooh, that's good. I'm glad you caught that. Okay.
Okay, so then for our test, it's 1.685. Did you get that?
Yeah.
Give your p-value, which is 0.096. Last question, which of the following best express the conclusion of this test? So we reject. Wait,
Yeah, but
we reject.
we
So,
reject and there is sufficient evidence to conclude that there's a difference in the mean cost.
tickets purchased 14. So the third one? Wait, hold on.
No, it's
the mean
the
purchase days advance compared to 90 days advance. Wait, where's the difference in here? Cost? No, oh, because it says no difference. There is a difference. Okay, got it.
Okay, I missed one.
Which one?
I missed. Number 3. Wow.
3? It's way up there.
It's not the one we clicked. Maybe it is C.
So 3, we put the last one.
Yeah.
Okay. So then the distribution of means of each sample normal since the data we have been determined is normal. Okay.
Try that one. Yeah. That's the only one I got wrong.
Oh, that's impressive. That's the only one we got wrong. Woohoo! Well, last time, that makes me feel good because last time I remember that this preview thing was a lot harder than the actual exam. So hopefully that's the case again.
Oh, I'm not going to bet on it.
Not this time.
We got
Okay,
number
let's see what
3.
you got.
Number 3 is it? Oh, I got one wrong.
I got 100. Wait, what'd you get wrong? So yeah, number 3 is right.
So the distribution is because the data has been determined.
I got 28 wrong.
28?
Yeah, I put the last one.
It's the second to last one. Oh, honey. Okay, I think I have to go.
Yeah, it's the second to last one. All right, thank you so much. Good luck.
Yeah, good luck, guys.
Hello? Hello? Were you able to do that? Alexis, were you able to change the question? Hello?
What?
Were you able to change 28? Hold on one second.
I can do it. It's just the second to last one, right?
Yep.
Okay, and that's the only one I got wrong, so that's fine.
All right. Perfect. Good luck. We'll see
Good luck.
you Monday.